Fine. So, fine. I think we have looked at most of the stream classes. Fine. There are two important ones which we have to look at. One is the object input stream and the object output stream. Okay. And there's also this print stream and the print writer. I think for that we know these classes basically. We have used them. We have used the print stream class already, right? So we know the methods from those classes, but it's only about how do we create objects of these, right? Okay, I think we can have a look at the API itself, the constructors which are available. And we have the print stream and the print writer classes. For example, if you look at the print stream, okay, the constructors here. Fine. So constructor says, okay, you can create for a file. A print stream can be created for a file. Fine, which would mean that it creates a new file. Okay. Fine. And you can also be specifying a character set name, because this is converting from string to bytes basically, and what goes in a file is bytes. Okay, or it could be a char set object as a string character set name or a char set object, or you can have any output stream as a destination. Fine. Also mark one more parameter type here, which is boolean for auto flush, and we'll see what this auto flush is. But yes, a print stream as well as a print writer can have a auto flush. Fine, it can be set as true or false. Okay, the same thing, output stream, but instead of character set name we are calling it as encoding. Okay, fine. So it's the output is mainly meant for either some output stream or a file. Fine. Okay. Fine. Only difference here is, if you look at these constructors where output stream have been used, fine. Okay. So we have these three constructors. In case of a print writer, we have all these constructors. One thing is, in print writer you have all these constructors, additional two constructors where, fine, these two constructors where instead of a output stream you can also use a writer, and you can specify a destination writer. So print writer is a second level as such, fine, it's a second level stream or a second level. Even the writer as such is second level, though it is not subclassed from filter writer, because it writes to another writer. It can, fine, it will be able to write to another writer also. Okay, fine. So if you look at the print stream or a print writer, or a print writer, fine, both of them. Constructors would take parameters as, so you can create from a file. See, the very in version 1.0 and 1.1, the very basic constructors which were provided, there were few constructors, there were not so many constructors, They were just, okay, if you want to create a print stream, you can create with the help of, so a print stream constructor was like this. You have some destination output stream. And a boolean for auto flush. Okay. And if you don't specify the second parameter, only give an output stream, then auto flush by default is false. And auto flush by default is going to be false. Okay. If you look at a print writer on these lines, okay, so for print writer, yes, we have the same constructors, plus you can specify a writer for your output and a boolean for auto flush. Fine. And it can be an output stream. Destination is an output stream here, or in case of print writer, it can be either an output stream or a writer. Okay. Fine. In case of print stream, yes, you also have an option of specifying a character set name or the encoding to which it should be converted. Fine, encode in this. Okay, and if you look at other constructors, what are they? They are all about output stream being replaced with, okay, you don't get the auto flush thing, but instead of output stream, we have either a file object, which would mean that, oh, it should create a file output stream. Fine, or you can specify a string for the file name. Fine. Okay, so normally creating files, or you could have any output stream as a destination. In case of print writer, a writer is also allowed as a destination. So both are like second level streams. So if you have a print stream or a print writer, there is always a second level. There is a destination which is some output stream. Okay. Fine, and it's going to convert and write to the output stream. Fine. So, okay, now what are the methods for print stream and the print writer? What are the methods? We have the method called print, other is println. Okay, fine. If I consider println, what are the parameter? Both of these methods are overloaded. Fine, both of these methods are overloaded. You can specify any data type. So it's overloaded for all the types available. So for example, yes, you can use a byte, you can use a short, a int, a long. So any primitive you take, fine, it's available for all primitives, and it's also available for object. So any data type can be specified. Fine. Object covers all the reference types, and it's also available for primitive types. And print and println both have this. Only here for println there is one additional method where we don't have any parameters at all. Okay, println with no parameters is also available, and which would just mean, what is print and println difference? Println has a new line at the end. So if I just say println, just a blank line will be there. Fine. With no parameters means add a blank line. Okay. All these methods, since they can take any data type, what they do? They convert it into a string first. Fine. The conversion of any type can be done to a string. We know how any data type is converted to a string. Fine. For reference types, it's a toString method. Fine, and for all others string conversion is available. Okay, so converts to a string, and then that string is what is pushed to the destination. Of course, if this is an output stream, right, which is bytes, a character set name has to be used, some encoding has to be used for conversion. If not specified, there is a default character set which should be used. Okay, and so this can write to any output stream, but it's a string which is being written out. It's a text always with the help of print and the println method. It's all about text basically. Print stream and print writer is all about writing text. Okay. And other methods other than the print and the println, because this is what we have most commonly used. We have used other method also. What is the other method? We have the method called printf. Fine, we know the parameters for a printf. Fine. Fine. And we also have just like printf, the other method exactly same working as the printf method. You have the option of, instead of saying printf, you could also use a method called format. And so we have the printf and the format method, and these are the most common new methods. Yeah, but this one is overloaded. Fine, lot many times. Print and the println for all kinds of data. Fine, so printf and println and format, they also format and give a string output, and they also convert to a string. Okay, fine. So this is about the print stream and the print writer classes. Okay, let's look at the two important classes. One is the object output stream and the object input stream. Object output stream, a direct subclass of the output stream, in the constructor takes as parameter another output stream. Yeah, it can take as parameter another output stream. Yeah. And we have the object input stream also on similar lines. Okay, so if I have to create an object input stream, it would take as parameter another input stream. See that output stream which you pass to in the constructor for object output stream, maybe it's a file output stream, and so destination becomes a file. Okay. Fine, it's not necessary though. Fine. I mentioned that yes, we can have output streams which write to the network. Okay. So destination could even be a network and not necessarily a file. Okay, and it's general. It could be any output stream. Okay, the additional, what methods does it have? It has all the methods of data output. Fine, writing all primitive types, write chars, write bytes, write UTF. Okay, additional method for our object output stream. We have an additional method, returns void, name of the method is write object, parameter is object, and it throws. What does it throw? Okay, IO exception, a subclass of IO exception, not serializable exception. Not serializable. Okay, what is this not serializable exception? Why this not serializable exception? This is something like clone not supported exception for clone method, right? Fine, recollect clone method. It's a method available on any object, fine, to create a copy, but then it can also throw clone not supported exception. Fine, similarly, this method called write object on an object output stream. So you have an object output stream which has a destination for an output stream. Fine. What we give to this is some object. Fine. What is this supposed to do? What is the write object method of the object output stream supposed to do? Whatever object is given, yeah. Copy means what? Object. It should store the values of its fields, all the instance variables. That's what it is supposed to store, right? Fine. Any instance variable is there, so it is supposed to convert your object into a sequence of bytes and puts it across to the output stream. The process of converting an object into a sequence of bytes, which is meant for persistence, okay? The idea of those bytes is, it should be said that later, whenever required, using those same bytes, it should be possible to recreate the object. Fine? To create an object, fine? That should be possible from those bytes. Okay. So with that purpose, we are writing the bytes there. Okay, to understand this serialization process, fine. So one thing, yeah, whatever object you give should also be implementing the interface called serializable. If it is not implementing serializable, no, this conversion to bytes will fail. It won't convert to byte size. Okay, throws an exception, not serializable exception. Okay. To understand the serialization of an object, fine, let's take example of the account object, and let's try to look at the account object and see what all will be involved when someone tries to serialize an account object. Fine. We have the account object, and let's understand that maybe what we have done so far is we have defined account class, and then we'll say, okay, let it implement serializable interface. Suppose we made account to implement serializable, and we have an account object. So if I have look at an account object, how does it look like? What are the things in it? It has an account number, okay, that would be a long. It has a name. What is name? String. What does that object have? a reference to a string object where the name is available. It has a reference to the string object where the name is available. And reference type means you have references. Okay. It has a balance which is a long, and then what? It has a passbook which is a reference to a array list. We have used an array list object, so it has a reference to a array list object. What does the array list object have? Yeah. It has at index positions, it has got references. Reference to a transaction object. Right. What does a transaction object have? It has a reference to a local date object, and that's some local date object which internally has some values, right, for the date. It has a narration which is reference to a string object. It has a type which is reference to a enum object, account type, right? No, transaction type. And it has even a reference to a this would even have a reference to a, no, not reference here, sorry. Fine. This has got the amount of the transaction. And like this, there are so many objects. Now, let's see if someone says, oh, I want to store the account object, right? This is the object. Someone says, I am interested in storing this object. Fine. What should be persisted? What data should be stored? You'll store this. Will you keep the reference value? Or along with the reference, I should also have the other object. If this object refers to another object, is it good to store the reference? Reference may be something like location type of thing, but or we have to even store this. See, in order to serialize account object, it will also have to serialize the string, the name.
एक्चुअल में serialize क्या है? वो serialize word का क्या मतलब?
Converting object into a sequence of bytes for purpose of persistence, and we would like to be able to retrieve it or recreate later. So some information needs to be stored, right? What all information will need to be stored? No, it can't be the reference value, but rather it should say, okay, oh, that's a string object we have. Fine. In order to serialize account, I will need to serialize the string. In order to serialize this account, I'll also need to serialize the array list. In order to serialize this array list, I'll also need to serialize transaction. And in order to serialize transaction, I'll need to serialize those three things. It's a whole object network. Fine. Here you are looking at things in a hierarchical fashion. In some cases, you have an object referring to something, and that one again referring back to the same object. So it could be any kind of a network of objects. You have one starting object, but this leads you to so many objects. And it might be circular thing. Right? So when you serialize, the whole object network needs to be serialized. Okay. So if I am serializing account, I'll have to serialize string. Is string serializable? Yeah, oh, we go to the API and say, oh, string is serializable. So there won't be a problem serializing this. While serializing account, I'll also have to serialize array list. Is array list serializable? And we find yes, it is serializable. While serializing the array list, it has to serialize transaction. Is transaction serializable? We have not made it serializable. Clear? So, write object for this account would fail. So, when we are saying, oh, it's not just the account which has to be serializable, the entire object network needs to be serializable. It's not one object which is serialized, it's a whole network of objects which is serialized. Okay, and every object in this network must be serializable. Okay, fine. And just understand one thing, write object failure is very serious thing. If write object fails, just see, look at the state of this stream here. Look at the state of the stream, object output stream. What is the state? Okay, it started writing, fine. As it is serializing and then it comes across something in the network which is failing, what would happen?
Wrong result.
What happens to the state of the stream? It doesn't know what state it is in, because the other thing is only partially done and it can't retrieve it back. You have written something out, you can't be taking it back. Maybe you have pushed something to the network, so it's a partial thing. Okay, so failure of an object, write object method is going to be a very serious thing. Okay, relatively fine, because in this we don't know the state of the stream. Has it written any bytes at all, or fine, or how much of bytes it has written out already, fine, and that can't be corrected then. Okay, fine. So state becomes undefined for the object output stream. Okay, if it fails, the state is undefined. Fine. So one thing is about classes to implement serializable. The entire object network must implement serializable. The idea of writing object is later we should be able to read all that data and recreate the object, right? Okay. So what kind of data will go here in the output stream? We understand the values of the instance variables must be there. But when I am writing my object, it's not just the plain values which I can put there. And you can't just be putting plainly the values only. Fine, if I just put only values and someone says, okay, I am reading some object, but then when he is reading the object, he needs to know what object this was stored. The name of the class whose object is being serialized, that definitely needs to be sent out first, and then the values can be sent out. Okay, and so when you are serializing, one of the things which has to go is name of the class whose object is being serialized. Okay, fine. So class name, fine. That's one thing which should go here. So which should go to the output stream. First the class name. So it will say, I am writing account object, fine, and then starts putting the fields of the account, values for the fields of this account object, and then when there is a sub object, it will also say, oh, now I am writing a string here, fine, and then it will push the details of the string object. Okay, so one thing, each time it has to serialize any object. Serializing an object also involves writing the name of the class whose object is being serialized. Okay. Another thing is, associated with a serializable object, and associated with the serializable object is a 64-bit value. There's a long value called, so we have one long value. Name of the variable is serial version UID. This is of type long, fine. This is going to be a static and final variable, and this is nothing but a static and final variable in a class which implements a serializable interface. So when you have a class which implements serializable interface, okay, you don't put this. Okay, you may not put this as a variable there, but when the compiler compiles a class which implements serializable, the compiler introduces a static and final variable, type is long, 64-bit value, which is a serial version UID for your class definition. And why this has been done? Okay, why this has been done? Okay, see, we initially started with one definition of account class. We had some definition of account class with some number of fields. Okay, so let's say we had a version where we didn't have the passbook, and we had implemented serializable, we had stored some account object, fine. Later a modification was done to the class definition, and then from what was stored earlier, I am trying to say, okay, let me read that object. I had stored something there which was an account. Let me try to create the account object from that data. What will happen? Yeah, when it reads, it sees, okay, there is a class called account whose object has been stored. Okay, and then loads a class definition which is currently there in your machine. I have only stored the name, not the whole definition. It would be too costly to keep on storing the entire definition. It's like putting the entire class file into that. So you don't put the entire class file. Okay, but at least if there is a change, if this is a different class definition than what was stored, I must be able to detect that and give an error saying, okay, this is not the same class definition which we had stored earlier. You don't have the same class definition now. Your class file doesn't match the object's class file which has been saved earlier. Okay, and for that reason, fine, when we compile, the compiler generates a serial version UID which is dependent on what all methods are there in this class definition, what all instance variables are there in this class definition. Fine. It looks at all that aspect and creates a hash value, 64-bit hash value, and that is what is a serial version UID. Okay, so if class definition changes, this computation would yield a different value. And the serial, when you compile again with some change in the class definition, the serial version UID would have changed. Now, what is stored when I say write object? It's not only the class name, it's followed by a serial version UID of the class. So when you say write object, okay, class name, this class whose serial version UID is this, account class with this serial version UID, and then follows the data part. Fine, clear? the write object method. What does write object method do? It will say, okay, I am going to store values for the instance variables. See, write object means only instance variables. It's about object. If you have a static variable, no, that's not same. It's not the state of the static variable, state of the object. Fine. So what I am storing currently is an account object, it will say that. But not only putting name is not sufficient, it should also put the serial version UID along with it. Fine. Because I am storing when the serial version UID was this. It's this definition. Okay, so class is identified not only by the name, but along with the name, the serial version UID. Okay, then you know exactly, okay, this is my structure only. Fine, or it's a different structure, there is a change, or this is a different one. So when someone uses read object, he will get an error saying your class definition doesn't match this one. You don't create some wrong thing. Find the significance of a serial version UID. Other thing is this serial version UID, which is a computed value, normally a computed value. Even what you can do is you can have declare this. When you write a class definition, you are free to declare this static variable, public static final long serial version UID equal to, and you can push your value there. Okay, and you could also be putting your some value, whatever you feel like. The type is long. Fine, but then it would be your responsibility that if structural change is there in the class definition, you need to have a different serial version UID for it to know that yes, this is different, it has changed. Okay. Find write object method, what it does? Stores the object. Fine, in the current state. Fine, it's not only one object, it is storing the entire object network. Okay. So when you do a read object, you are actually supposed to do a casting, because what is read object? Yeah, if you look at the object input stream, so method in the object input stream returns object, name of the method is read object, and yeah, and what does this read object throw? It would throw class not found exception. See, you have stored an object into a file, you carry this file to some other machine where you don't have this class definition at all, or the serial version UID don't match. Okay, it's a different class definition then. Okay, so it has throws for class not found exception also. Okay, one is class not found exception here. There's a IO exception and there's a class not found exception. Fine, one is IO exception, other is a class not found exception. Okay, so when we do a read object, we will normally be doing a cast operation on it. Okay. Other thing I was mentioning was when we use read object, and I mentioned yesterday that when we use a read object, it recreates the object without using the constructor of that class whose object has been created. Fine, that's what I mentioned. Okay, but it doesn't say that there are no constructors used. It's not that way. Okay, when someone marks a class as serializable, okay, that means he gives a permission that objects of this class can be persisted. You can save it somewhere. Normally, I may not like to have my objects being saved. Okay, so normally they are not allowed to be saved. If you want them to be saved, okay, allowed to be saved using write object, you are saying okay, implements serializable. That's what you are doing, right? Okay, so here is someone having some kind of a class called class A. He designed this class and he didn't like the idea of persisting objects of type A. Okay, he doesn't want persistence for this, so he doesn't mark it for serializable. He has got some instance variables, right? There are many instance variables and they may be private. We got someone becoming smarter and says, okay, you don't implement, I'll create a subclass, I'll inherit what you have. I have this class B, I'll mark this as serializable. I'll mark this as serializable. So A is not serializable, B is serializable, which is a subclass of A. B has maybe added a few more instance variables to this. Okay, and B says, okay, I'll implement serializable. And when he stores objects of B, so object is created from B, fine, so you have type B equals new, fine, whatever it is. And someone says, okay, let me now store the object of B, thinking that anything here is also getting stored because that's part of the object of B. Object of B, whenever it is allocated, has space for instance variable of its superclass also. They are not accessible. But if the object of B is created, all instance variables which are in A is also getting allocated. And you are saying, okay, B is something which I can persist because I have declared it as serializable, and I say write object, what do you think goes? What do you think is getting stored? Are the instance variables of A getting stored there? It shouldn't be. The one who has designed A never wanted it to be, and it won't be. Okay, this won't be done. Now coming to the point of someone using read object method of to recreate the object of B. And what will be saved? The instance variables of B, their state has been saved. And when someone uses read object method, the object of B will have to be recreated. Fine. Here is the object of B, where there is space for variables from A, fine, and there is that space for variables from B. Okay. Now initialization for variables from B will take place by reading the values which come from deserialization. You have serialized and you have deserialized. But what about the initialization for the instance variables of A? How will it be done? So when we use the read object method, fine, it's creating the object of B, but it is also using the constructor of A, so that the part related to A gets initialized. It's using the default constructor on A. Okay, it uses the default constructor for A, so that the variables related to the A part instance variables of A, they should also get initialized. You can't have something uninitialized. They get initialized with the constructor. Instance variables of B are initialized from the deserialization process. Okay, maybe you even had a further subclass called C, because B is serializable, C is automatically serializable. If you had added this, and maybe this is an object of C, fine, initialization for B and C will be done from the deserialization part. It's a constructor of A which will be used. Which constructor? The no argument constructor of A would be used here. So whenever we have a deserialization, the read object method is invoked. The object which is being created, no, the constructor of that class will not be used. Okay, but the first non-serializable superclass, the first non-serializable superclass, oh, that's the one. From here it is serializable. The first non-serializable superclass, for that non-serializable superclass, the default constructor is going to be used. And suppose it happens like this, that this class doesn't have a no argument constructor. Class A doesn't have a no argument constructor, has constructor with parameters only. Fine. In which case, the write object method for B or C would fail, because this is something which cannot be deserialized.
तो उसको अगर पैरामीटर कंस्ट्रक्टर है ही तो ये
पैरामीटर वाला है ना कंस्ट्रक्टर.
ये तो हो रहा है सर.
हाँ, this has got parameterized constructor but not a default constructor. Which constructor should I use? What parameter value should I pass? Oh, I am reading from the file and I am creating an object. I know instance variables for B and C, but I don't know what value to set for the instance variables for A. Fine, it will fall in that scenario. So for initialization for instance variables of A, it has only the option of using a no argument constructor. But if that's not available, no point. I'm not going to even use the write object method. Your write object method would fail in that case. Read object, it knows read object can't be done, and therefore write object is failed there itself. You can't serialize itself. Yes, oh, B is serializable, I am creating object of B, I am using it in write object, my object network is serializable, but write object can still fail. I have exception. Fine, clear on this point now? Okay. Fine, serializable and fine, what is serializable? Okay, there is one keyword. Now, a different scenario. We have our account class. So, here is a very simple account object, not our. So, in which we got variables like account number, name, balance, and there's one more variable which is PIN number. Yeah, I have a PIN number as a variable in my account object. Right. Now, PIN number, do you think when someone uses write object, this should be allowed to be stored the normal way? Sensitive thing. You might have in your object, you might have some fields, some instance variables, which should not be persisted in the default manner. When I use the write object method, the default persistence is used, the default serialization is done. No, this should not participate in the default serialization. I have a field which should not participate in the default serialization. If you have such fields, you can declare such fields to be transient. Just declare transient. This won't be persisted in the default manner. Your default write object method would skip this field. Okay, so you can declare fields to be transient if required.
Public static transient.
Private, it's a private field. Whatever the type may be, not static. Static variables do not participate in serialization at all. So it's only meant for instance variables. Fine. So any instance variable may be declared to be transient. Fine. So that it will not participate in the default serialization. Fine. So the keyword transient. So transient and static members are not participating in serialization.
जिनका serialization नहीं होगा
Skip करना है इसको. Fine. For example, pin number. No, I don't want that to be serialized. Initialization may be done by reading from some other place, a secure channel, some other way to get it initialized later.
सर तो पिन नंबर स्टोर तो करना पड़ेगा स्टोर
Not the normal place. Fine. So I might have some more secure channel through which I will read later once I have created the object and then get it initialized with it from some other place. Fine. But not along with all other things.
सर तो ट्रांजिट जो है वो वेरिएबल डिक्लेयर करेंगे
Instance variable, normally you have instance variables, so some instance variable may be declared to be transient. जैसे static बोलते हैं वैसे. And just the way you say static, some variables are static. Static means not part of the object anyway, so they don't participate in serialization. But transient is an instance variable, and it's in the object, it's part of the object, but still in serialization, no, it's not participating there. Fine. So its initialization would be using the default value, null or 0, right, or false, boolean, numeric or reference type. Fine. When it is read back, it has to be still initialized. So initialization is your default initialization for the transient field. Fine. Okay. So we have the object input stream and the object output stream. Now let's come to the exercise. Okay. Fine. What we have done so far, we have created a bank clerk, okay, where we can, it understands commands, okay, it's working on bank, and in this bank various account objects have been created which are part of the map. Okay, so now what we want is, yes, we would like to be able to save the bank data, the entire bank data. So bank is one object. We can have object of the class bank, which we can save into a file. And we can save the bank data into a file. When I serialize the bank, it's going to serialize the account map. It's a tree map which we have used here. Tree map is serializable. Okay. While serializing the tree map, it will also serialize account. We'll have to have bank to be serializable, we'll have to have account also to be serializable. While serializing account, it will also be serializing transaction. Fine. So all three we may declare as serializable, and let's add a method to the bank class. Fine. Let's add a couple of methods to the bank class. So we can add a method which is returns return void. This is for the bank class. Okay, in the bank. Okay, so in bank we want a method called save, no parameter specified. You can have throws IO exception here, and you can have a throws IO exception here. Okay, what this save method will do? Save into a file, and for the file what we will do is we will use bank name as the file name. So what is the name of the bank? Fine. So example, if it was HDFC, yes, we will have what is the bank name, and we will give an extension of .bank. Fine. For example, it will come out to be something like HDFC.bank. So we want to create a file in which, so we will have a file like this with the extension of .bank, in which we store our, we serialize our object and save that data. Okay, so one method is save, to save the object, and then we should be able to retrieve the object. Retrieve object means we would actually create the object of bank. By reading this from this file, we should be able to create the object of bank. Okay, so it's not an instance method, it would be a static method. So we can add a static method in the bank class to return a bank object. Create a bank object for me. Name of the method can be load, and you can have as parameter a string for the bank name. So given the bank name, fine, try to locate a file with this name. Fine. Fine, you can create a file input stream, create an object input stream, use the read object method, and you should get object of bank. Because this is not on the, you don't have the object of bank when you want to call this method. When you want to call this method, we don't have object of bank to call this method. We don't call it on object of bank. Rather, this would give me the object of bank. Okay, fine. So we add these two methods to the bank class, and then add a constructor, not constructor, add one more command. Oh, we have those commands with the bank clerk understands. We add just one additional command called save. So if you say save, it should call the save method on the bank object. Fine. Save is a method, right? We have created commands for the bank clerk to understand. We say open and followed, we have the syntaxes. And so there we'll add one more command for it to understand. It should be able to understand a command called save. So when someone gives the command save, it's then at that time it calls a method called save. Okay, and other change what we would like to do is on startup, right? We are taking the bank name and the bank code as input, right? Yes, we take the bank name, and for this bank, if I find there is a file existing, okay, for this bank name, if I find there is a file existing, then I'll not use the constructor of bank to create the object. I'll not even ask for the bank code. I should load from that and create the bank object and use it. Fine. So bank object created, if file is existing, created from the file with the help of load. If file is not existing, then default, then we have a constructor. Use the constructor, ask for the bank code and use the constructor. And the way we are currently doing. Okay, and this method and this command called save. Fine. Okay, so let's make these changes. And we have to change the bank class in the account class, or we'll have to make serializable, right? And we have the bank and bank, all three. I think we'll have to make changes in all three. Okay, fine. What's the change in account? What's the change? In account. It implements and also the class called transaction. When another point, we have a enum here, right? Enum, the enum class, which is super class for any enum type, implements serializable already. Okay. Fine. So that's a change for account, change for bank. Should I put a star here? There's so many things. Fine, we want to add a method called save. Okay, let's have a method save. We want to have a throws here. Throws IO exception. Yeah, what do we do? And someone says save, what do we do? File output stream. Created from this dot name plus dot bank. Fine. And create a object output stream. Okay. save the current object, and fine. See, either we do like this, or what's the other option?
Try find.
Try we don't need the auto closable. Try with resources. This is known as try with resources. Look at the try block. It's not fine. This is parenthesis, and this is in parenthesis. Try and then in parenthesis like this. And we have a block for execution. We don't say finally at all, right? Okay, this is known as try with resources. Things have to be auto closable. Yeah, those two objects which we are creating inside the parenthesis, they are auto closable. They implement auto closable. Okay, fine. Same way, let's also first add the method, then we'll compile, right? So we want to add the method public static method returns bank object. Let's call it as load. It takes a bank name, throws and class not found on IO exception. Yeah, we can have a try. Yeah. Yeah, what do we do in the try? File input stream, new file input stream created from the bank name plus, it's a parameter to me now, bank name, right? Okay. Return casting to a bank, okay, this is bank clerk. What's the change? Adding one more command. Okay, acha. So in this commands which we have list, and let's add save here. bank dot save. Fine, we'll do two things, right? We'll need a try here, right? And here two things, bank dot save and we need to give output, okay, println. And so when someone says save, we'll say okay, saved successfully. Okay, so this is also done, and we have the main method and where the object was created, right? We are using command line arguments here. Achha, if args is not specified, then we have the command line arguments. Okay. Enter the bank name. So bank name has been accepted here. Fine. This is a place where we have the bank name. Okay. Let's create a file object. Created from bank name plus dot bank. If bank file dot exists, okay, just let me check. You have done here, right? This what I'll do is I don't want it's the same variable. I'll see. Let me declare initially, okay? Bank equals null. Okay, we have a declaration for bank variable, and here is where we'll say if bank file exists, when we find that this is existing, then bank equals bank dot load from the bank file, bank name, sorry. Yeah. Okay, else all this. So creating bank object is either with this, or else you take the bank code, okay, and create a bank object using the constructor.
सर पर हम सेव तो खाली टोस्टिंग मेथड का वही कर रहे हैं ना, सेव मेथड में आपने यूज किया ना दिस,
हाँ, this save, right object, this means the bank object. This means the current bank, the bank object on which you call the save, that object needs to be saved. That is the object which will go to the object output stream. It's going for the right object, right? It's a bank object. What is this? The object of bank class on which you call saved. and we are calling save here, right? And we are in the bank clerk, we are calling the save here, bank.save. Fine. Let me just check whether we used import. We put catch for the IO exception, right? Yeah. Okay. Okay, file, we need the import for the file. This is in bank clerk. Okay. Okay, we have the class not found exception as well, right? The load method. So we need a throws, maybe we can put a throws in the main, and so that should take care. And if I put a throws, okay, this will take care. Okay, and let's run and make it full screen. Okay, and there's no file yet. There are no objects. Okay, and open. Name and opening type is current opening balance, and then and let's save this. Oops. It's for the penalty. We have the penalty object in the current account class, and we have not, that's not serializable. It's a function object, but anyway, we can also have that also to be serializable. Fine, let's remove the bank file now. Fine, we'll have to remove because this is useless. And we have to make penalty to be serializable. This is import java.io. Huh? Okay. No, this is an interface, so we have to just say extends. Okay. Oops. Yeah. Okay, let's quit. Let's run again. Yeah, it's there. Fine. So once we save, yes. Next time when we run, yeah, it's there. It's not a text file. Xtump minus C. It's a binary file, no? Okay. Fine, this is what is there. Yeah, some text would also be there, right? What has been saved is, it's most of it is binary, right?